Okay, guys. So in these next three questions here, all right, what we are going to be doing is we're trying to determine if these vertices make a parallelogram. And if you notice, all right, I'm asking you to do it three different ways. One of them is using the slope formula, one of them is using the distance formula, and the other one's using the midpoint formula, okay? Now, on a test or a quiz or whatever we're doing, all right, in online learning, I'm not going to specify which one that you have to do, all right? So you guys can kind of pick which one, but I do want to show you guys examples, all right, of each of these three. So on the first one that's telling you you have to use the slope formula, and so we have to ask ourselves, well, how could slope help us prove that it's a parallelogram? And so if we look up at those 5 different methods, which one of these would be helpful with slope? Well, if we found the slope of each side, all right, wouldn't our slopes tell us if they're parallel or not, right? Because if two sides have the same slope, then those two sides are parallel, right? So when it's asking you on this one to use a slope formula, what we're really trying to find is if two sets of opposite sides are parallel. That's really what we're trying to determine, okay? So this one gets a little tedious though, because how many sides does that quadrilateral have? Well, it has 4 sides, which means that you'd have to do the slope 4 different times, okay? And so what I want us to do is just to sketch once again, all right, what this quadrilateral is going to look like. And remember what I said in my last video, it doesn't matter where you start, just as long as you go in the order it tells you. So I'm going to go A, B, C, and D. And so when I'm doing this, I need to find the slope of AB, the slope of BC, all right, the slope of CD, and then the slope of AD, okay? And what we're looking for is that the opposite sides have to be parallel, okay? Now, I'm not going to sit through here and go through the slope formula for all of these, okay? I'm going to just kind of tell you what I got. So for the slope of AB, all right, I got 1/7, all right? For the slope of BC, I got -6. For CD, I got 1/7. And then for AD, I also got -6. All right, so if you look at those 4 slopes, it's obvious that I have 2 sets of sides that are parallel, all right, because I have 2 sets of slopes that are the same, okay? So the answer to this is yes, and that's because we've just proven that we have 2 sets of opposite sides that are parallel, okay? Let's go to the next one. So the next one now says, determine if the following vertices make up a parallelogram using the distance formula, all right? So the distance formula in those 5 different methods of proving it as a parallelogram, all right, would prove to us that the opposite sides are congruent. So once again, how many times would I have to do the distance formula? I'd have to do it 4 different times, one for each side, right? This is always the one that's never chosen, all right? People don't typically do the distance formula 4 different times, all right? But once again, if I sketch this out, J, K, L, M, I'm going to need to find this distance of JK, of KL, of LM, and then of JM, okay? So just like for the slope, I'm not going to sit here and work through those distance formulas. All right, I'm going to tell you what I got. Make sure it matches with yours. Like, you should definitely be doing it, okay? So, oh no, I don't have my answer key for this one, okay? Let me see if I have it on a different one. Okay, well, it looks like I'm going to be sitting through. Oh, nope, okay. All right, so I actually do have the answers. Okay, so for JK, all right, I have the square root of 26. All right, for KL, I have the square root of 53. And then for LM, all right, I actually got the square root of 37, and I actually stopped there, all right, because I don't need to go any further, because if you look at my opposite sides of JK and LM, all right, do they match? No, they don't, all right? So automatically, I know that this is not, all right, going to be a parallelogram, all right, because those opposite sides don't match, all right? They're not congruent, okay? All right, so for my last one, it says, determine if the following vertices make a parallelogram using the midpoint formula. So if we go back up to that list, all right, and ask ourselves, well, which one of these is dealing with midpoints? Which of those 5 different methods would help us, would the midpoint help us? And it's going to be number 4, where if the diagonals bisect each other, all right, that means that they're meeting at the midpoint, right? So what we're going to do on this one is we're actually going to focus on the midpoints of the diagonals. So what I'm going to do is, once again, sketch my quadrilateral, all right? I'm going to start down here and do A, B, C, D. And so I need to look at what are my diagonals, and my diagonals are going to be BD and AC. If it's a parallelogram, then that midpoint has to be the same of AC and of BD, all right? So what I'm going to do is I'm going to find the midpoint of BD, and then I'm going to find the midpoint of AC. If they match, then it's a parallelogram. If they don't match, then it's not a parallelogram, okay? So let's find the midpoint of BD. So it's going to be 2 plus 3 divided by 2, comma, 6 plus 1 divided by 2, which gives me a midpoint of 5 halves, comma, 7 halves. And you can turn that into decimal if you want. All right, it doesn't really matter. All right, for AC, I'm going to have 0 plus 5 divided by 2, comma, 0 plus 7 divided by 2, which gives me a midpoint of 5 halves, comma, 7 halves. And if you notice, those match, all right, which means that, yes, it's a parallelogram, okay? All right, so I'm going to pause there, all right? I'm going to come down here and do maybe 1 or 2 of these proofs, all right? Not all of them, okay? Just so that you guys can see what these proofs are going to look like.